Okay, another tidbit, and again using a comparison to programming, this time around functional programming, is, so we've talked about it's the R. This time we're talking about the R, which is the axiom of replacement. And the axiom of replacement is actually this whole thing about how you take a relation, specifically a functional relation, and the image is guaranteed to be a set. Again, you see this language that all of the construction axioms basically expand the definition of what is a set, which is super useful because in collaboration with the first axiom, it makes it so the number of things you can do with transitioning between the predicate land and the proposition land grows larger and larger. But the simple way, or the simple thing that I use to remember the axiom of replacement is, again, just to think of programming, this time around functional programming, for the function dot map. And it means that if you have an array, 1, 2, 3, whatever, and I go dot map, I have to give it a lambda function. I haven't done the lambda function term. I think this is what it is in Python. Lambda x squared. In this case, I'm just doing x squared to all of the array elements. What the axiom guarantees is that the image of this lambda function, or in the math language it's called a functional relation, the image, okay, let's see what that would be. That would be 0, 1, 4, 9. This is guaranteed to be a set, which is pretty cool. Now, unintentionally, what it allows you to do is you're allowed to do restricted comprehension, which is where you go, give me all of the x. Actually, I don't want to get into this because I might make a mistake. But yeah, good way to remember R is that it's essentially the dot map operator.